What if I told you there is a place in our solar system where the year is shorter than the day? No, this isn't some sci-fi plot twist. This is the reality on our cosmic next-door neighbor, Venus. It's a world so bizarre, it makes you wonder if the universe is just making stuff up as it goes along. We call Venus Earth's sister planet. But if that's true, it's the evil twin sister who sets the house on fire and laughs. Stick around, because by the end of this video, you won't just understand why Venus is so weird, you'll have a whole new appreciation for our own little blue marble. The answer is stranger, hotter, and spins in a way that breaks all the rules. So let's start with something we all get. Earth's one spin on its axis is a day, about 24 hours. One trip around the sun is a year, about 365 days. Simple, right? We've built our entire lives, our calendars, our everything around this rhythm. Now, let's hop over to Venus. It takes Venus about 225 Earth days to complete one orbit around the sun. That's its year. Pretty zippy, right? But here's the kicker. To do just one single rotation on its axis, one single day, Venus takes a whopping 243 Earth days. Let that sink in. K-Day on Venus is longer than its year. You could celebrate your birthday, blow out the candles, and still have about 18 days left before the sun finally sets. It's a mind-bending contradiction that makes Venus one of the strangest places we know. But why? Why does our sister planet spin so incredibly slowly and in the wrong direction to boot? To unravel this mystery, we need to dive deep into a story of planetary chaos, crushing atmospheres, and maybe even a cosmic collision of epic proportions. Let's peel back the layers of this planetary onion. First up, the simple explanation. All planets, when they were forming, were basically giant, chaotic mosh pits of rock and gas. This swirling cloud, called a protoplanetary disk, orbited the young sun, and everything was generally spinning in the same direction, counterclockwise. This is why most planets, including Earth, still spin that way today. This spin is called prograde rotation. But Venus spins clockwise or retrograde. It's the solar system's rebel. Only one other planet, Uranus, is as weird, spinning on its side. So, what happened to Venus? Now for the complication. Here's where it gets weirder. One leading theory is the giant impact hypothesis. Imagine billions of years ago, a young Venus was spinning along just like everyone else. Then, bam! It gets smacked by a massive object, maybe another protoplanet the size of Mars. This cosmic haymaker didn't just knock Venus silly. It was so powerful, it could have completely stopped its spin and then sent it spinning slowly in the opposite direction. It's like hitting a spinning top so hard it wobbles, stops, and starts spinning backward. This is a pretty solid theory, and it explains a lot. But wait, there's another, even more mind-bending idea. What if it wasn't a collision at all? What if Venus's own atmosphere is to blame? This is layer 3, the cutting-edge stuff. Venus has an incredibly thick, heavy atmosphere. It's about 90 times denser than Earth's. The pressure on the surface is equivalent to being almost a kilometer deep in our ocean. It's an absolute crusher. This thick blanket of gas creates massive friction against the planet's surface. Over billions of years, this atmospheric drag, combined with the gravitational pull from the sun creating powerful atmospheric tides, could have acted like a giant brake. Imagine trying to run through molasses that's Venus trying to spin. This theory suggests that the atmosphere slowly, relentlessly, ground Venus's rotation to a near halt and may have even helped tip it over into its backward spin. So, it might not have been a single catastrophic event, but a slow, suffocating process that doomed Venus to its bizarrely long day. And here is a wow fact for you. The winds in Venus's upper atmosphere whip around the planet in just 4 Earth days. A phenomenon called superrotation. The planet's air moves 60 times faster than the planet itself is spinning. Talk about a windy day. So what does this all mean for us? Looking at Venus is like looking into a funhouse mirror of Earth. It's almost the same size and mass, made of similar stuff, and it's our closest planetary neighbor. Yet, it's a hellscape. Surface temperatures are hot enough to melt lead, and it rains sulfuric acid. Venus is a cautionary tale of what can happen when a planet's climate goes catastrophically wrong, thanks to a runaway greenhouse effect. Its thick carbon dioxide atmosphere trapped the sun's heat until the planet literally cooked. Studying Venus's bizarre rotation and its extreme climate helps us understand the delicate balance that makes a planet habitable. It shows us just how precious our own stable day-night cycle and our relatively thin protective atmosphere truly are. It makes you realize that being normal in this cosmic neighborhood is actually incredibly rare and fortunate. We didn't get hit by a planet-sized wrecking ball, and our atmosphere didn't decide to crush us into oblivion. We won the planetary lottery. So, let's recap this cosmic journey. We started with a simple, baffling fact. On Venus, a day is longer than a year. We explored how this is possible. Its year is a zippy 225 Earth days, but its day is a sluggish 243 Earth days long. We dove into the why, uncovering two major theories: a violent, planet-altering collision in its distant past, or a slow, grinding break applied by its own superdense, suffocating atmosphere over billions of years. We saw how Venus is a terrifying yet fascinating example of a planet gone wrong, a stark warning right next door. It reminds us that the conditions for life are a knife's edge, and Earth exists in a delicate, perfect balance. Which leaves us with a final, thought-provoking question. If a planet so similar to ours could end up so different, how many other Earth-like planets out there are actually Venus-like hellscapes in disguise? Thanks for exploring the twisted world of Venus with us here at Sciences and Facts. I'm curious to hear your thoughts. Do you lean towards the giant impact theory or the atmospheric break theory? Let's hash it out in the comments below. And if you enjoyed having your mind bent by the weirdness of our solar system, show some love by hitting that like button. For more deep dives into the universe's biggest mysteries, make sure you subscribe and ring that notification bell so you don't miss a thing. See you in the next one.